So when we did this work yesterday, we worked with exponents, and when we multiplied two bases, the exponents got added together. When we dealt with division of two bases that were the same, the exponents were subtracted. When we dealt with something that was a power of a power, you'll see below, I have an example. In brackets, we're going to have 2 to the 3 raised to the 6. What we must do is we must multiply the two exponents to get our answer to be 2 to the 18, and then we evaluate using our calculator. Your job for the next few minutes is to pause this video, and I want you to try doing each of these problems to see if you got the concept that we studied yesterday. Now I'll start walking you through. So, because it's multiplication, we have to add the two exponents. 5 plus 2 is 7, and we end up with 2 to 7, which is 128. The next, we have 5 to the 5 minus 3, which is equal to 5 squared, which is 25. The next problem, we have to basically put our base as -3 in brackets, and we raise it to the 5 because we're multiplying the 2. So we end up with -243. The next problem, we have to put -6 raised to the, well, I'm going to write it out slowly, 8 minus 5, which ends up being -6 in brackets, still raised to the 3. So we end up with -216. Now, for the last one, we have some difficulty. I would just suggest that you pause the video here, review your power of a power, and then try these last two. With power of a power, like our example up here, we took the 3 and the 6 and we multiplied to get our exponent to be 18. Now, for 4 cubed raised to the second, what we're going to have is 4 raised to the, well, 3 times 2. Which ends up being 4 raised to the 6, which is 4,096. Try the next one on your own. Okay, here we go. Now, we write -7 raised to the, well, 2 times 2, because both of those exponents are 2. And then what ends up being -7 all raised to the 4, which calculates, when we punch it in our calculator, 2,401. Now, I've got to tell you, it's very important that when you punch this into the calculator, you punch it in with the -7 in brackets and then raise it to the 4. Otherwise, the sign that comes out of the calculation will be incorrect. So what we're going to do now is we're going to evaluate each of these problems with our calculator. 2 to the 0. Punch it in your calculator. You'll notice it's equal to 1. You do -4 in brackets raised to the 0. Guess what? It's also giving us 1. The same thing happens with bracket 3 divided by 4 raised to the 0. It still ends up being 1. 23 to the 0 equals 1 as well. The overall rule that we're taking a look at today is the zero exponent rule. And the zero exponent rule says that anything that is raised to the exponent 0, an x, a number, anything, always ends up being 1. Now that will always work as long as we do not have the base of our equation being equal to 0. Take a moment and copy down these tables. Each of these numbers are going from 2 down to -2, and the next column is 3 raised to the 2 all the way down to -2. So when we complete these tables, you'll notice the following. If I took a look at 2 to the 2 squared, we get 4. If I take a 2 to the 1, it's 2. if I take, well, the rule for anything to the exponent 0 is 1. And you'll notice that if I have 2 to the negative 1, that's 0.5. But I'd like you to realize that 0.5 is really 1/2. Then what I'd like you to realize is the next calculation, 2 to the negative 2, 2 to the negative 2 is going to give us basically 0.25, which is the same as 1/4. So what you'll notice is that anything with a positive exponent has a reciprocal for its negative. So if you think about it, in this case we have 2 to the 2 is 4, but 2 to the negative 2 ends up being 1/4. 2 to the 1 is 2, but 2 to the negative 1 gives us 1/2. So the key idea is to recognize when you have a negative exponent, all you have to do is remember, calculate the positive exponent first. So if I had 3 to the negative 3, I would figure out what 3 to the 3 is, which is 3 to the 3 is just 27. And then in order to get the negative exponent, you're going to write 1/27. Let's go through this process again, but this time we'll use 3 to the 2 all the way down to 3 to the negative 2. So let's use that rule that we just took a look at. So we have 3 squared, that's equal to 9. Then we have the following. 3 to the 1 is 3. 3 to the 0, based on our exponent law rule, anything to the exponent 0 is just 1. Now, 3 to the negative 1, all we have to do is remember that 3 to the 1 is 3. So that means 3 to the negative 1 is 1/3. And then 3 to the negative 2, well, we have to remember 3 to the 2 is 9. That means 3 to the negative 2 is 1/9. So what we can see is that for any base that we have, if its exponent is negative, so let's say I had a to the negative n, I could write it as 1/a to the n, and then simplify the a to the n. For example, let's take a look at this. Let's say I had 3 to the negative 3. I could write that at 1/3 to the 3, and then simplify the bottom half of this fraction. The bottom half of this to be anything that I want. I could simplify that to whatever I want. Now, what I want you to do is I want you to think about something that would happen if we had fractions. Now, we took a look at fractions and raising fractions to exponents in yesterday's lesson. But this time what I want you to recognize is this. Or, this is for fractions. So let's say I had a over b raised to the negative n. Alright, essentially what we have to do is, this is what I call the flip rule. I take the fraction and I flip it, and then by doing so, that removes my negative exponent. Remember, we flip the fraction and then remove the negative. So for example, if I had something like this, 1/2, let's say 2/3 raised to the negative 2. What we're going to do is we're going to rewrite this as, well, 3/2. So essentially, we flip this thing. We flip the fraction. And then the exponent, instead of being -2, becomes +2. Then what we're going to do is we're going to follow the rules from last time. If there was no exponent on anything on the inside, what we do is we transfer that exponent to all the numbers on the inside. So now we end up with 3 squared over 2 squared, which ends up being, well, just 9 over 4. Now what I'd like you to do is I'd like you to try doing some of these powers, and we'll take a look at it. And I'll put the solutions up for you. So now, using the rules that we had before, if we had 5 to the negative 3, we could write 5 to the negative 3 as 1 over 5 cubed. Now 5 cubed is just 125, so we end up having 1 over 125 as our final answer. For 6 to the negative 4, what we can do is we can write this as equal to 1 over 6 to the 4. By doing our calculations, what we should get is the following. 1 over 6 to the 4 is 1296. So it ends up being 1 over 1296. Now, I'm going to expose you to a new rule that we could add in conjunction with what we learned before. So before I told you a to the negative n is equal to 1 over a to the n. We can also say a to the n is equal to 1 over a to the negative n. So this part here, notice I have 1 over 2 raised to the negative 6. This means that I can literally go and change this to 2 to the 6. That is equal. Because I have a negative on the bottom, it's almost like you have a border wall. Anything that's negative, that's negative on one side of the border wall, we can move it up. In this case, it's on the bottom, so we've moved it up, so now it's just a straight whole number. So now we have 2 to the 6, which is equal to 64. And now, let's calculate this next one. We have negative 3 raised to the 4. Negative 4. So what we're going to do is we're going to use our rule, and we're going to have 1 over negative 3 in brackets still, but now instead of having negative 4, we have positive 4. And now computing that bottom part, we leave it as 1 over, well, 81. So we actually go and compute negative 3 to the 81. And you need to remember that this must be put in brackets when you calculate on your phone, or else you won't be able to get the proper sign for the bottom portion of that fraction. Now, what we're going to do is we're going to do this last question. We have 2 over 5 raised to the negative 3. And remember, this is what our rule was. So this is the fraction rule, I'd call it. So if I have a over b raised to the negative n, what we can do is we flip the fraction to be b over a, and then change it and remove the negative exponent, and then evaluate like before. So let's do that. So now, this problem, first thing we have to do is we have to flip the fraction. So we have 5 over 2. We're raising it to the 3. Then, once we've done that, we're going to apply the exponent to everything on the inside, the top and the bottom. So we're going to have 5 to the 3 over 2 to the exponent 3. And now we can calculate the top and the bottom separately. 5 cubed ends up being 125. And 3 cubed is just 8. And we're done. What I'd like you to do now is I'd like you to work on page 368, 2, 3, 6, and 7. Have a good day and a good weekend. See you Monday.